Welcome to the deep dive. Today, we're trying something a bit different. We're going to give you a shortcut, really, to understanding what looks like a pretty complex winter ahead for North America, the 2025-2026 season.
That's right. We've basically gone through a whole stack of recent climate studies, the latest model runs, forecasts, all of it.
And the mission is simple. Pull out the key takeaways, what you really need to know about the forces shaping your winter.
And it's important, I think, because this isn't your standard forecast story. We're seeing this really interesting mix of global patterns. It's definitely more complicated than just, say, El Nino or La Nina this time around.
Okay, so let's jump in. Usually, the Pacific and ENSO, El Nino, La Nina, they get all the attention. But the research we looked at points somewhere else, doesn't it?
Yeah.
To a really powerful signal emerging far away in the Indian Ocean.
Exactly. That's probably the biggest player, the main driver we're seeing, a developing negative Indian Ocean dipole, the NIOD.
Right, the NIOD. Can you break that down? What is that exactly?
Sure. Think of it like a temperature seesaw across the tropical Indian Ocean, east versus west.
Okay.
In this negative phase, the eastern part, over near Indonesia, gets unusually warm, anomalously warm sea surface temperatures. And the western side, near Africa, gets cooler than normal.
And we're seeing that happen now.
Oh, yeah. The latest observations show a really dramatic slip towards this state. The key index dropped significantly just recently. It basically confirms a strong NIOD event is, well, it's already underway.
Huh. And how does it get locked in like that? Is it just random ocean temperatures?
No, it's actually driven by the atmosphere interacting with the ocean. You get these unusual westerly winds starting up.
Okay.
These winds disrupt the normal ocean circulation. They stop the usual upwelling of cool water in the east, so the surface warms up.
Right.
That warmer water then fuels more atmospheric convection, basically more storminess, more rising air, and that convection actually reinforces those westerly winds.
Ah, so it feeds back on itself, a loop.
Precisely. It's a self-sustaining, positive feedback loop. It makes the pattern stronger and helps it stick around.
And the models, what are they predicting for this NIOD going forward?
Well, here's the thing. There's really strong agreement among the major international climate models.
Right.
They all point towards this NIOD continuing to intensify and persist right through our autumn and into the early winter. It could get pretty strong, potentially.
Wow, okay. So Indian Ocean, major factor. But we can't ignore the Pacific entirely, right? What about La Nina? I heard a La Nina watch was issued.
That's right. The Pacific is currently neutral technically, but yeah, a watch is out. Most models do suggest we'll see a La Nina develop.
A strong one, like the NIOD.
No, that's the key difference. The forecast is generally for a pretty weak and likely brief La Nina, mainly for autumn and early winter.
Okay.
And importantly, there's a lot more uncertainty, more disagreement between the models about this La Nina compared to the NIOD. For the NIOD, the consensus is really high. For La Nina, it's a bit more murky.
And all this is happening while the whole planet is, exceptionally warm overall. Does that background warmth change how these patterns play out?
That's a really important point. It likely modulates things. But interestingly, the sources suggest that even this week, La Nina might be playing a role, sort of like a catalyst.
Catalyst for the NIOD.
Yeah, potentially helping to nudge the atmosphere in a way that actually supports the development of the stronger NIOD event. So even though La Nina itself might be weak, its presence might actually increase our confidence in the NIOD forecast.
Okay, so we have these big ocean patterns. NIOD is strong, La Nina weak, but maybe helping. How does that stuff way out there actually affect the weather where you live here in North America?
Right, through these things called atmospheric teleconnections. Think of them like atmospheric bridges or pathways that link weather patterns across huge distances.
Gotcha. Invisible highways in the sky.
Kind of, yeah. And there are two main ones relevant here. First, the Pacific North American pattern, the PNA. That's the one we often link with La Nina.
And that usually means?
Typically, it helps funnel colder, drier, Arctic air down into the western and central parts of North America.
Okay, classic La Nina effect.
But then there's the other key player, maybe even more important this year, the Indian Ocean North American teleconnection, or IAN. This one directly links that IOD warming in the eastern Indian Ocean to a pattern over us.
And what pattern is that?
Generally, it favors warmer conditions in the eastern part of North America and cooler conditions in the west.
Ah, okay, so wait. In the west, both patterns, the La Nina PNA and the NIOD INA, seem to point towards colder.
Exactly. They reinforce each other out west. That gives us pretty high confidence in forecasting colder than average conditions there.
But in the east, They're fighting each other. The La Nina influence pushing cold, the Nano D influence pushing warm.
That's the perfect way to put it. The East becomes this sort of atmospheric battleground. You've got competing influences, which means temperatures are likely to be highly variable. Big swings are possible.
Okay, that makes sense. Now, you mentioned one more piece, right? Something about the pole.
Yes, the polar dimension. We need to look up, way up, at the stratospheric polar vortex over the Arctic.
Right, the vortex. We hear about that a lot in winter.
So when the vortex is strong and stable, it keeps the coldest air locked up near the pole. But if it weakens or gets disrupted,
The cold air escapes southward.
precisely, it can plunge down into the mid-latitudes, bringing major cold outbreaks. And here's the connection. There's a known statistical link, a pretty robust one, between La Nina conditions and a weaker polar vortex.
Oh, interesting. So La Nina increases the odds of the vortex breaking down.
It increases the odds of disruption, yeah. Something called a sudden stratospheric warming, or SSW, which is basically a major breakdown event. The chances are notably higher during La Nina winters.
And are the early forecasts suggesting a weak vortex this year?
They are, yes. Early long-range signals point towards a weaker than normal vortex being more likely, particularly in the first half or middle of the winter.
So that adds another layer of risk for cold snaps, especially for the central and eastern U.S.
It definitely elevates that risk, yes. It increases the likelihood of significant Arctic outbreaks pushing south.
Okay, let's try and pull this all together. We've got the strong NIOD, the weak La Nina, the potentially weaker polar vortex. What does this mean regionally for you across North America this winter?
All right, let's synthesize. Based on these drivers, here's the most probable picture for winter 2025-2026. First, for the north and west, think Pacific Northwest, northern Rockies, northern plains, extending into the Great Lakes. High confidence here for a colder and snowier than average winter overall. We could see some impressive mountain snow out west and frequent Arctic air intrusions across the northern tier.
Colder and snowier north and west. Got it. What about the south?
For the south, southwest, southern plains, southeast, also high confidence, but for the opposite. An anomalously warm and dry winter is expected. This is a very typical La Nina signature, unfortunately, and it could definitely worsen any existing drought issues.
Warm and dry south. Okay. And the east. The battleground.
Right, the east, northeast, and mid-Atlantic. This is where confidence is more moderate because of those competing signals. The seasonal average might end up near normal, but that hides the real story, which is likely to be significant temperature swings. Big ups and downs.
So periods of mild weather, but also
Also an elevated risk for some high impact, though maybe relatively brief, cold air outbreaks spilling south. And importantly, the potential for major East Coast snowstorms is there, especially thinking about the Great Lakes and maybe the interior Northeast, fueled by that clash of air masses and available moisture tracks.
It's interesting you mentioned the Southwest being dry based on these dynamics, but I saw one source, the Farmer's Almanac, actually predicted a wetter winter there.
Yeah, that's a notable forecast discrepancy. The dynamical models driven by these large-scale patterns strongly suggest dryness, while the almanac goes the other way. That's definitely a key point of uncertainty to watch as the winter gets closer.
Good point. So wrapping up, it's really a unique setup this year.
It truly is. You got this strong, persistent, negative Indian Ocean dipole really steering things, combined with a weak, maybe short-lived La Nina, and overlaid with the potential for a disrupted, weaker polar vortex. It's quite a mix.
So thinking about all this, what stands out most to you from our deep dive today? How these incredibly distant ocean phenomena can actually reach out and influence the kind of winter you experience? And maybe a final thought to leave you with. Knowing about these complex global drivers, these connections, does that change how you might think about or prepare for those potential cold snaps, or maybe even significant snow that could be heading your way this winter?